Hi, I'm Professor Goings. Welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in college mathematics, you're in the right spot, so go ahead and click the subscribe button. That said, let's get into the current video. I'm going to talk about what are called level curves, and this is something that you'll see in your Calculus 3 class shortly after you are introduced to what's called a multivariable function, and these are used as an aid to getting a graph of a multivariable function. So let's see what the definition is and what these things look like and how they help me graph a multivariable function. So, definition. For a function z equals f of x, y. So I have this function of two variables and a constant c. So c is going to be a fixed real number. The set of solutions to the equation f of x, y is equal to c is called a level curve of f of x, y. Okay. So let me go ahead and do an example just showing you how to find a level curve, and then we'll do an example where we'll find a handful of them and then again use them as an aid to graph the multivariable function. So let's say I've got the following. F of x comma y is equal to y over x squared. Find the level curve f of x, y is equal to 3. Okay, so solution. Looking back at the definition, again, I take the function equals a constant, and then I'm going to extract the level curve from that. So let's see how this is done. What I'm going to do is I'm going to start with f of x, y is equal to 3. And then I'm going to replace the name of the function with the expression for the function. That says y over x squared is equal to 3. And then I can turn this into something that we're familiar with from, say, pre-calculus, right? Y is equal to 3x squared. And therefore the level curve is the parabola stretched by a factor of 3 starting at the origin, okay, and it would be this guy right here. So that would be my level curve, f equal to 3. Now, I haven't even really described how these are part of the graph, or how they're not part of the graph, but how they help me as an aid to graphing the function. So let's go ahead and take a look at that in the next example. Let's consider the following. F of x, y is equal to, let's do negative y plus 4. Okay. Let's do a couple of things with this. For one, let's find some of the level curves. So find the level curves f equal to 1, f equal to 2, f equal to 3. And then from there, what we'll do is we can kind of get a general idea of what the rest of them are. So find those level curves and use them as an aid to graph f of x, y. All right, let's go ahead and see how this is done. So, solution. F of x, y is equal to 1 was the first level curve that I mentioned. And then what I'll do is I'll replace the function name with the function expression, giving me negative y plus 4 is equal to 1. add y, subtract 1, I get y is equal to 3. So we see that the level curve f equal to 1 is the same thing as the line y equal to 3. How about f of x, y equal to 2? Okay, same idea. Negative y plus 4 is 2. Add y, subtract 2, I get y is equal to 2. So the level curve f equal to 2 is the line y equals 2. Last one, f of xy equals 3. So negative y plus 4 equals 3. Add y, subtract 3, I get y is equal to 1. So I've got these three level curves, f equal to 1 is the line, y equal to 3, and then so on and so forth over here. So let me go ahead and sketch those on an xy plane. Okay. So the line y equal to 3 and I'm going to label these both ways. I'm going to say this is y equal to 3, which was the level curve f equal to 1. And I'll talk about what that means here in a moment, but let's just kind of get these plotted. So y equal to 3 is the level curve f equal to 1. Second, let's do f equals 2, which is the line y equals 2. Okay, so this is the line, and again, this is the xy plane. So this is the line y equal to 2, which was the level curve f equals 2. And then finally, let's do the level curve. Let's see, I'm not sure if this color will show up, so let me see. Yeah, I don't think I like that one as well, so let me not do that one. So let me try, let's do this color. Okay, so this would be the line y equal to 1, which was the level curve f is equal to 3. Okay, clean that part off the screen here. Okay. So now that I've got that, let me clean this side up, and then I'm going to show you how to graph the function. The graph of the function is going to be in R3, right? The xy plane is the domain, so that's going to be where the inputs are, and then the graph is going to be this plot of all the z values. So let's go ahead and let's sketch R3. And again, x, y, and z plane. Now, graphing functions in 3 dimensions is significantly more challenging than graphing it in 2 dimensions. So what I'm going to do is I'm only going to sort of indicate what happens like in the first octant, which is where x, y, and z are all positive. And so what I'm going to do is I'm going to take these portions of the level curves in the first quadrant, and I'm going to plot those in the xy plane, which is part of the first octant. Xy plane, which is part of the first octant. So y equal to 1, which is the level curve f equal to 3, and we kind of match the colors up here. So that one was, what color did I use there? I think it might have been this one. So let's see, is that, yeah, it's got to be that one right there. Okay, so that would be, this is the line y equal to 1, so that would be here. And let me redo that. It really should be parallel, of course, with the x-axis because it's a constant function, or in other words, a line here, so that way should look like, okay, that's good enough. So that'd be the line f equal to 3, but let me leave those labels off for a moment. The next one would be y equal to 2, which is the level curve f equal to 2, so that's going to go right here. The next one is the line y equal to 3, so that's going to go right here. Okay, and remember what those represented. Okay, now let's look at the level curve f equal to 3. So that was this one right here. This was f equal to 3. Well, let's remind ourselves what that meant. So f of xy equals 3. Remember, the definition of the level curve was this consists of all the points that satisfy this equation. In other words, all the points which have a function value 3. So that means for every ordered pair on this line as an input to the function, the point on the graph has a z-value of 3. So directly above this line, sitting, say, somewhere up here, I don't know if that makes sense, kind of angled wrong way for you guys, maybe like that. I guess something like that. All the function values would be 3. So let me see what color I could use here to indicate that. I want to use a different color. Let's see if I try to use blue. Let's try to use green. Okay. So directly up above this, all the function values would be 3. So that would look like that. For this one here, this was the level curve f equal to 2. That means all the function values were 2. And then for this one, all the function values were 1. And the idea is, what this generates is a plane. So this is the plane, f of xy equals, what was it, negative y plus 4. But remember, f of xy is z, so this is z equals negative y plus 4. And put it in standard form, add y to the other side. This is the plane, y plus z is equal to 4. So using level curves, we were able to generate the graph of a plane. Okay? Let me do one more quick example, and then I will wrap up. The next one I'm going to do is a slightly more complicated function. It's going to be a slightly more complicated graph, but ironically, it's actually a little bit easier to sketch. Let's take a look at the following function. F of xy is equal to x squared plus y squared. Okay? That expression, the x squared plus y squared, should look familiar, right? That's the expression that's used in the equation of a circle centered on the origin. So let's take a look at some of these level curves. The level curve f equal to 1 means I've got x squared plus y squared is equal to 1. The level curve f is equal to 4 would be x squared plus y squared is equal to 4, so on and so forth. So let's take a look at the sketch of the level curves and how that relates to the graph. Okay, so x, y, and z. Okay, the level curve f equal to 1 consists of the unit circle centered on the origin, so that would look like this. Okay, so that's the level curve f equal to 1. The level curve f equals 4 would be the circle centered on the origin of radius 2. And look like that. And let's remember what these represented. The level curve f equal to 1 consists of all the ordered pairs whose function value is 1. This right here tells me what that solution set looks like, and it's this circle. Therefore, for every single ordered pair on this dotted line, those are all input values for this function. If I plug one of those ordered pairs in here, the function value is 1. So directly up above that dotted circle, I'm going to get part of the graph, which looks like this. Okay, and then directly up above this blue dotted line, which consisted of the level curve f equal to 4, in other words, the set of all points that have function value 4, would look like this. Okay, and if I were to plot every single point, in other words, or if I did just a bunch of different level curves, what I'm going to find is the following. The graph of this function looks like this. Okay, and this is what is known as a paraboloid. Any cross section of it is actually just a parabola. Okay, But anyway, this is how you can use what are called level curves as an aid to graph multivariable functions, in particular, more specifically, multivariable functions of two variables. Certainly we're not going to be doing any drawing of graphs of multivariable functions of variables with 3 or more inputs. But thank you for watching. Please consider subscribing.